video. So actually, you're gonna get 7 videos for this week. I left off talking about how metamorphic rocks are formed by an increase in pressure, an increase in temperature, and/or the presence of chemically active fluids, hot water usually. And these rocks change due, due to being buried deeply under the ground. So those sedimentary rocks can get changed into metamorphic rocks. What happens though? What do you think is going to happen as more sedimentary rocks are laid down on top? What's going to happen is eventually those metamorphic rocks will be so deep underground and that they're going to melt because it gets hotter the deeper you go underground, and they're going to become magma again. So you see, this is a cycle. You're going to make igneous rocks again, and those are going to break down and make sedimentary rocks, and those are going to get buried deeper and make metamorphic rocks. And what they're trying to show you with this rock cycle is that every rock has had a previous history. Almost every rock you're going to see was something else, and then through this rock cycle became another type of rock. It's kind of interesting. What drives the rock cycle is the heat within the earth. The deeper you go in the earth, the hotter it gets. Okay, there's your rock cycle. Let's go back to this then. You can read through this. They talk about it in the book. All the things we just talked about in terms of the rock cycle. Plate tectonics. We talked about that a little bit. We went from Wegener to Hess and Dietz. Finally, to Tuzo-Wilson. We talked about the plate boundaries. And here's a new word that we need to get familiar with, and that is the asthenosphere. What in God's name is he talking about? What is an asthenosphere? Well, let's figure it out. Probably, I don't know where you went to high school, but in most high schools, they always show you this diagram, showing you what's inside the earth. So we all know that we have these layers in the earth. The layer we're living on is the crust. Beneath that is the mantle, spelled like a fireplace mantle. Underneath that is a molten outer core. That's interesting. It's liquid iron. That's what it's made of, liquid iron. And the inner core is made of solid iron. So you got 4 main layers. People always ask me, how deep is it to the center of the earth? It's about 6,378 kilometers, about 4,400 miles. But what is the asthenosphere? Getting back to that word, the asthenosphere. Well, when plate tectonics came out in 1967, we added on to those 4 layers that we just talked about. Now we talk about a lithosphere, which contains the crust and the uppermost part of the mantle. Beneath the lithosphere is another part of the mantle called the asthenosphere. And beneath that, the lowest part of the mantle, they didn't write it in, so I'll write it in for you. It's called the mesosphere. Mesosphere. Anyway, what is the asthenosphere here? Well, the lithosphere, ladies and gentlemen, are the plates. So when the plates move, it includes the crust and the uppermost part of the mantle. And they slide on top of the partially molten, that means partially liquid, sort of like asphalt, asthenosphere. The lithosphere is rigid, and it slides on top of the partially molten asthenosphere. That's how plate tectonics works. Could kind of think of it like this, like the froth in a pot of convecting stew, or you could think of it an orange. Go to the grocery store and get an orange. The lithosphere, the plates, the lithospheric plates are like the orange rind, and the pulp underneath it is the asthenosphere. Kind of think of it like that. It might help. So the plates are made of lithospheric plates. They're not just crust, they're also the uppermost part of the mantle. and they slide on top of the asthenosphere. The crust there's two kinds of crust. We've got continental crust underneath the continents. Right now, you're on the land, I assume, and therefore you're you're on top of the continental crust, and your house is on top of the continental crust, and it's about 50 kilometers or 30 miles deep. The oceanic crust is the crust underneath the oceans, and it's a lot thinner. It's only 10 kilometers or 6 miles deep. That's real important to remember. There's two kinds of crust: continental crust, which is a lot thicker, 50 kilometers thick, and oceanic crust, which is 10 kilometers thick. The continental crust is made up of lower density rocks. What is density? Do you remember what density is from science class? Density is mass divided by unit volume. And so, if something is denser, it's heavier for its size. The continental crust is lighter. Please don't forget that for the next chapter. That's going to really help. Continental crust is lighter in weight. And the igneous rocks have less iron in them, so it's less dense. The oceanic crust is made of a black rock, mostly called basalt, B-A-S-A-L-T. I've learned, though, in Tennessee, people call it basalt. Basalt, whatever. It's a black igneous rock. That's what the oceanic crust is. So if you were to swim to the bottom of the ocean and look at the oceanic crust, it would be black. Why? Because it has iron in it. And the iron gives it the dark color. It also makes it more dense. It's heavier. That'll hold you in good stead if you remember that the oceanic crust is thinner and denser, and the continental crust is lighter and thicker. We'll talk more about it later because if you understand that, it's going to help you understand plate tectonics. The mantle, what is the mantle made of? Well, the mantle is made of a rock called peridotite. There's a spelling for you probably never heard this word before. Peridotite is igneous rock, and it's green in color, black and green. But the green is what you want to remember. It's peridotite. It's an igneous rock called peridotite, and that's what the mantle is made of. The outer core is made of liquid iron, and the inner core is made of solid iron. Later on, we'll talk about how we know that. But for now, just remember, we got the crust, oceanic and continental crust. The oceanic crust is thinner and denser, made of basalt and igneous rock. The crust is made of sedimentary and igneous rocks, but the igneous rocks in the continental crust are lighter in color and less dense, and the continental crust is thicker. Then we got the mantle. It's made of peridotite. The outer core is made of liquid iron. The inner core is made of solid iron. Geologic time. We talked about James Hutton. The result, therefore, of our present inquiry is that we find no vestige of a beginning. Actually, we said, the result, therefore, of a present inquiry is that we find no vestige of a beginning and no prospect of an end. What he was saying back in 1788 is that geologic time is immense. That's what that's part of uniformitarianism. That Earth history is huge. It's not like James Ussher said, the 6,000-year-old Earth, with his old idea of catastrophism. The Earth is much older. Now we know that the Earth is 4.6 billion years old. Don't forget that. The universe is 13.7 billion years old. How, in God's name, do geologists know that? We know it because of radioactive isotope decay. The way radioactive isotopes decay, it's like an atomic clock, and we'll take a look at it later on. But all of the data gives us 4.6 billion years old. The oldest rocks on the Earth are 4.4 billion years old, so we know the Earth is at least that old. But the whole solar system formed at the same time, and so we know that um, the Moon is mostly made up of 4.6 billion year old rocks. The Earth must be the same age as the Moon. Various meteorites that strike the Earth are 4.6 billion years old. And we've used all kinds of different radioactive isotopes. We always get the same number. From the greatest universities in the world, Harvard, Stanford, Oxford, Heidelberg, Tokyo, they all give us 4.6 billion years old. So that's how old we think the Earth is. We could divide Earth into um, the, these units, which we call the geologic time scale. The largest unit of geologic time is called an eon. Eons are broken down into eras. Eras are broken down into periods. So if you had a multiple choice question on the next test and it asked you which is the largest geologic time scale unit, the one that covers the most time, what would it be? It would be an eon. What would be the smallest? A period. The 4.6 billion years of Earth history, and I'm going to get a better picture of the geologic time scale than the one in your book. Is called, okay, so the geologic time scale eons, broken down into eras, broken down into periods, broken down into epochs. Well, let's take a look here. Well, actually, this one's not that good. Let me get a better one here. God, it's huge, isn't it? Later on, if you take historical geology, you're going to have to memorize a lot. But for now, let me just tell you. Um, okay, I'll just write it out here. Um, the eons are the largest subdivision of geologic time. There are 4 eons. Eons, E-O-N-S. The first is called the Hadean, and it goes from 4.6 billion years ago, BYA, to 4 billion years ago. The next eon of geologic time is called the Archean eon, and it goes from 4 billion years ago till 2.5 billion years ago. Next eon is the Proterozoic eon, and it goes from 2.5 billion years ago till 542 million years, MYA, millions of years ago. The last eon, the eon that we are living in, is called the Phanerozoic eon, and it began 542 million years ago, and it ends today. So it goes to now. What eon are we living in? The Phanerozoic eon. Okay, what's the oldest eon? The Hadean. Eons are broken down into eras. Let's take a look at that. For example, the Phanerozoic eon is broken down into 3 eras: the Cenozoic, the Mesozoic, and the Paleozoic. Latin is very useful. Paleo means ancient, so this is the era of ancient life, Paleozoic. Meso in Latin means middle, and that's the era of middle life, Mesozoic. Ceno in Latin means recent, and that's the era of recent life. So these eras are based on the dominance of different life forms. Paleozoic, the most advanced forms of life were fish, invertebrates, amphibians, and then some reptiles. The Mesozoic era was dominated by the dinosaurs. You can see here that the Mesozoic era goes from the 245 million years ago to 65 million years ago. The Cenozoic era, from 65 million years ago to now, is dominated by mammals. We are mammals. Humans are classified as mammals. Mammals are life forms that have body hair, high intelligence, the mothering instinct. Mothers protect their young. They Most mammals don't lay eggs. Only two primitive mammals lay eggs. And mammary glands that females have to give milk. That's another characteristic mammals have. There are many other characteristics we'll talk about later on, like we have a four-chambered heart. Reptiles have a three-chambered heart. Anyway, what are the three eras of the Phanerozoic eon? Paleozoic from 542 million years ago to 245 million years ago. The Mesozoic era from 245 million years ago to 65 million years ago. And the recent era, the Cenozoic, from 65 million years ago till now. Eras are broken down into smaller units called periods. You don't have to memorize all these now. There's too much to remember right now. But just remember, eras break down into periods, and periods break down into epochs. This is called the geologic time scale. It took more than 100 years to get the geologic time scale to work. And a lot of work went into it. Scientists all around the world. Geologists, what kind of tools do we use? Well, we always have a magnifying glass to look at minerals real careful. I'll provide you with one. A hand lens can also be used to magnify. We look at maps. When we're identifying minerals, we use a magnet to identify minerals like magnetite. Dilute hydrochloric acid. This is acid that is used to identify a mineral later on called calcite, and you'll learn how to do that. Don't get it on your fingers because it'll burn. Hydrochloric acid, it's not real strong. There are stronger acids like sulfuric acid in your battery in your car. That will burn straight through your skin and start dissolving your bones. So that's even worse. But probably the worst is hydrofluoric acid. I use that on my PhD for my project, my dissertation. The mafia uses hydrofluoric acid. Growing up in New Jersey, I lived around people who were in the mafia. Yo, Vinny, he didn't pay the bill. Go drop him in the hydrofluoric acid. You know what I'm saying? Capiche? Afterwards, we'll have a cannoli. If you're Italian American, don't take offense. I'm just joking. I've got a lot of Italian friends. It was just a joke. If you don't have any humor, then classes get boring, don't they? Anyway, we look at rocks and minerals using microscopes as well. We use seismographs to record earthquakes. We use X-ray analysis. We use electron microscopes. There's all kinds of different equipment that geologists use depending on what your job is, and that's what I love about it. It's almost like being a detective, and you're trying to solve a really difficult case, and only you're trying to interpret what happened in the past, or you're trying to find minerals or oil or gas, or you're trying to solve some sort of problem, environmental problem, for example. It's a lot of fun. And science denial. Some people say that climate change is a hoax, and I'm not on the loony left. 99% of scientists know that the Earth is warming up. There's no doubt about it. We have temperature records. We have melting ice caps, hurricanes. Hurricanes are caused by the heating up of the ocean. We have more and more hurricanes. Some people say that smoking doesn't cause cancer. That's science denial because all the data shows that smoking these causes cancer. I hate this coronavirus because I got to sit on the sofa and teach you instead of meeting you in person. But at least I get to smoke a cigarette and not get in trouble. In fact, I think it'd be a great recruiting tool if we had grown state cigarettes and passed them out to the students. I'm just kidding. I'm just joking. God. Anyway, so some people say the Earth is flat, you know, or evolution doesn't occur. Uh, I tell you, evolution does occur, and it doesn't mean there's not a creator. In fact, I think it's the opposite, actually. And many scientists, Darwin was not an atheist. He knew that because species change does not mean that there's not a creator. People mix things up. Darwin never said we came from apes or monkeys. So there's lots of things that you can read on the internet that are false. And many priests and ministers and pastors believe in evolution. So they're two separate subjects. The scientific method works, and it's how we learn. It's the best way of learning because it's being intellectually honest. And we have the greatest minds in the world. That's what's great about the human race is we're able to solve complex problems using the scientific method. But if I have one piece of advice now that I finished chapter one, my one piece of advice is don't start smoking these things. I can't quit. I was in the army, in the artillery, and the cigarettes were cheap at the PX, and all my buddies smoked, and I learned this damn habit. Anyway, that's the end of this lecture.